So now we're going to be talking about solutions. We have an isotonic solution. What does that mean? That the concentration is the same inside and outside. So the net movement of water or fluid is going to be equal to each other. So there's zero net movement of fluid. Okay? So pretty much the cell will stay the same size because it's not going to shrink and it's not going to burst. Okay? Okay, so now we're going to be talking about hypotonic solutions. What does hypotonic refer to? Inside the cell or the solution? You told me last time it was the... Inside. No, it was the solution actually. It's fine, it's fine. So, if it's hypotonic solution, what should the molarity be on the outside? Should it be high or low because it's hypo?
Low.
Low, exactly. So the solution outside of the cell is low. What is the solution inside of the cell?
High.
What is the molarity?
High.
It's relatively high, right? So again, when you're saying hyper or hypo, in this case it's hypo, it's always talking about what's on the outside, which is what's going to be the solution, right? Okay, good. So in this case, where is water going to flow?
Inside?
Inside, exactly. Now, that's not talking about these circles or the solids. Water is what's going to come inside. So if water is being added to the cell, is it going to shrivel or get bigger? If water is added to the cell.
It'll get bigger.
It'll get bigger. And it'll get bigger and bigger to a point where it might even like burst, right? Like if you had a water balloon and you just keep adding water and water, more water to that water balloon, eventually what's going to happen? It's going to like
burst.
Burst, exactly. Now we're going to be talking about the hypertonic solution. Okay? What does the hyper mean? That means there's a high concentration of solute outside of the cell. Okay? And tonic refers to that we're dealing with a solution here. Okay. In this example, where is there a higher concentration? Outside or inside?
Outside.
Outside, because we see 6 circles here, and the concentration is 6m, which is the molarity. How many, what is the molarity inside? What number?
2.
2, exactly. So, thinking about osmosis, in osmosis what happens? The water is the one that's moving, right? From a high concentration to low concentration. So in order to, balance out the concentration, water in this case is going to go from inside to outside. Okay? That way, water will be added to this solution so that you can achieve equilibrium. Does that make sense?
So that means that the 2 is going to go outside?
No. Water. Water only is going to be moving outside and inside.
Okay, so the water is going to go outside, which is going to make the cell shrink.
Exactly. The cell, very good point. So what's going to happen to this cell? It's going to kind of look like a raisin because it's going to shrivel up. So you asked for it. What are we going to talk about now? You can't say it? It's phagocytosis. In phagocytosis, just think about eating, right? Like you're eating a sandwich. Mm-hmm. That's what certain cells in the body do, like the lysosome and the macrophage. They eat stuff up. So if you had one word to describe phagocytosis, would it be like eating or pooping?
Eating.
Eating. Okay, good. Okay, so now let's talk about pinocytosis. Phagocytosis we talked about as like eating, right? That was the one word I wanted you to know. So if we're eating a pizza, that would be phagocytosis. After eating our pizza, we want to drink a beer, some Dos Equis, right?
Yeah.
Yeah, cerveza, baby. And what is the word for drinking? When the cell drinks? Pinocytosis, exactly. Good. So now we're going to talk about receptor-mediated endocytosis. Why is it called receptor-mediated? Because it's mediated by a receptor, which is right here. Okay. So if something binds to the receptor on the outside of the cell, since it's the word endocytosis, is it going into the cell or out of the cell?
Into the cell.
Into the cell. So what does the receptor do? It just helps this, in this example, this triangle or substrate, get into the cell through invagination, which means it's going into the cell through a vesicle. Okay.